Hi everyone, my name is Ryan Arnold. I'm the Toolchain Engineering Manager for Linaro. I'm here to present on Toolchain collaboration, which is basically Linaro and ARM and whomever else, member companies speaking about what we're working on in the Toolchain, GNU Toolchain and LLVM Toolchain, talking about what we've done and where we're going, I guess in the foreseeable future or the near future, next 6 months outlook. I'll also be presenting with Matthew, Brett, and Dan, former Linaro Toolchain Working Group Tech Lead, and now working at ARM. I don't know what your title is.
Engineering Manager and Compilers.
Engineering Manager and Compilers. So we'll go through Linaro's slide deck, and then I'll pass it off to Matthew, and then he'll go through his slide deck. All right, so I'm going to sit down to give the presentation. All right, so starting out, I'm just going to take a look at Linaro's high-level roadmap for this year. So SFO15 is now and moving into next spring and then beyond spring. So anything in yellow is long-term, which means don't base anything off what you see in yellow, because those aren't guaranteed. Priorities can change. These tasks could be refined or they could be dropped, and so we're not sure, but those are what we kind of want to focus on in the future. But what's really important right now is what's in blue and what's in green. And I'll speak toward these individually later on in the presentation. I guess the big ones right now are the blue ones. Those are probably the really interesting ones. And I'll get to those as we get to them, or as we hit the slides. Just notice, please, the ongoing effort in the bottom. If you don't see something you're interested in the top, please look in the bottom. It might be covered in the bottom. So I'll just kind of go into each of the individual projects, and you'll see these things brought up in those projects. All right, so starting out, I want to talk about delays and risks. So we've been working on a number of things that you saw in that previous slide deck, but there's always delays and there's always risks in all of those things. So some of the big delays that we've had recently are in Sanitizers. We're discussing how to support differing virtual addressability sizes. Depending on how your kernel is configured on your machine, you might have 39-bit or 42-bit, and there's recently some discussions on making 48-bit the default. So we're having discussions about how do we support that dynamically. This is sort of a developing conversation right now. So there is a bit of a delay there. You can't just code away. So that's going to kind of wait to drop until the Linux kernel support is available at Demerval. Do you know where the Linux kernel discussion is on that?
I believe they stall it between if they're going to make it 48 or other VMA as default. Okay.
So we'll just wait to do the full implementation until then?
No, they cannot have support for all the 3-bit VMA size, but I believe 48 is not still the default.
Okay. Okay.
And I don't know where or when will become the default one.
Okay.
Some of the kernel guys are here. It may make sense to find some time to talk about this.
I think it was Catalan who was doing it.
Vindican is here, so
okay.
He'll know enough.
I can also, it's a box. I also can say that some machines actually explicitly need 48-bit.
Yeah, it's probably going.
So I can say a Thunder dual socket Thunder 1, needs 48 bits because the 48th bit says what node the memory is located on, which is the physical bit, and you have to have physical matching with virtual.
So nonetheless, that discussion's still ongoing, and it doesn't make sense for us to do too much upfront work. Also in delays, LLD, Demerval did a bunch of work when he first joined us, and then the community decided to refactor the back end. Ultimately, it's a good idea, but it's put a bit of a delay on LLD moving forward. I think we're pretty much able to move forward at this point, right? The refactoring work is complete. We've also found that LTO is broken in trunk. Maybe that'll clear up pretty soon.
So Yes, it is broken in trunk for building Chromium. Yes, it is broken in trunk if you have different command line options.
Here.
But it does work for
So we're
things where you have a single command line option, that is
right.
benchmarks.
So we're opening bugs on these issues. We're opening bugs on these issues and moving forward, but you know, it's delayed because of that. As far as risks, there's a lot of new contributors to LLVM in AR64, taking up a lot of time in maintenance. Bots are broken quite often, maybe too often. We can talk more about that later. We're finding that AR64 systems of all types struggle under validation. So we're having some problems getting some of our releases and snapshots out. We're testing a number of combinations that others aren't. And like I said, we're having some struggles finding system configurations that are able to handle our workloads. And also, GCC6 stage 1 won't be open much longer, so everybody's got patch sets in flight. Hopefully we can all get them in by the time it closes. Any other risks that anyone else is aware of to our schedule? Guess I didn't talk to my team entirely before I put this together. No? All right, so I'm going to go through individual projects and just talk about some of the things we're working on and where we see ourselves going. So in glibc and binutils, we'll start with binutils. We contribute there as needed. That's a pretty low maintenance project in general. I think ARM handles a lot of work there. When you guys have a new ISA version, you do a lot of the work there. So we work there as needed. In glibc, we're looking at implementing some build bots for ARM and AR64. I think, Ramana, you and I are going to speak about that, probably have a conversation. We have some ideas about rebooting Malik improvements. I think we're starting to get a sort of a collective will to do that finally, or do it again, try again.
I'd be really.
You'll be.
So I'd be happy to see that happen. I think it's significant performance improvements.
Yeah, it's a hard
Malik.
problem, and it's hard to get everyone to agree on what's important.
Yeah, I think when you did it last time, it was the first thing was to decide what's an improvement to malloc.
Yeah.
You know, it's what makes a memory manager better than the memory manager was the difficult problem.
Right.
And then it's relatively easy to actually do that once you've decided.
Right.
So I have a question. The general improvements to malloc, will they start with contributing benchmarks or micro benchmarks for the malloc so that we know what we are optimizing and improving?
Sidesh and I were discussing this in a Demerval. Maybe one of those guys could speak about what some of their ideas are. Oh, yes.
So we have a couple of micro benchmarks for malloc already, but they're not sufficient. So I think the general approach that Ad Hammerwall is looking at is trying to make the fast path lock-free, which you won't really have a benchmark validate that in the beginning, but eventually you should. Maybe Ad Hammerwall can elaborate on what your idea is.
Because I believe for ARM it's the same for some of other architectures that I used to work on PowerPC board, and the main issue is a lock path that is hit on every malloc, which is on the other memory allocations like tcmalloc or gmalloc. They don't have this, and it shows a lot of performance improvements on a lot of benchmarks, not little benchmarks, on the workloads, real workloads. And I believe that's the idea I'll be pursuing, trying to optimize the fast patch. I was discussing with Sidesh that some scenarios like allocating on a thread and deallocating on another thread, it will still be difficult to try to come up with a better solution than the one currently now. But I believe trying to reach for a lockless patch for common usage should yield a lot of improvements right away. What I'm not certain if I could be able to adjust current glibc algorithm to make this happen, or if if you need to come up with a new algorithm, a new architecture from scratch to make this happen. It is something that is still debatable.
So somebody on my team has been also writing some micro benchmarks for mallocs, and he's actually been writing his own malloc just for fun to some extent, and we can contribute some of those benchmarks back when I look at them, because I have not looked at them yet to see what he's done, but I think we should be able to contribute it back, at least the benchmarks part and everything.
So if they want a quick review, they can. If they want a quick review, they can CC me, and I can take care of that. Yeah. Either way.
Just to make sure it's not embarrassing. I know.
Yeah, but so we are looking into malloc ourselves because we've been seeing malloc showing up in real code, and we've been looking at writing our own malloc and everything. But I think if we can, I've been trying to steer him to push back to glibc, but he's not a normal toolchain person, so he's kind of scared of that the community. So, but I'm not, but he is.
All right, so I want to keep us going. I've already taken too much time. We're going to be working on glibc release management. I believe Demerval volunteered for the next glibc release. We're going to do some out-of-tree testing. I want to enable cross-testing. That's been a long time desire of mine. I don't know if it's going to happen. It's been on my to-do list forever. I'd like to see it happen. And then a difficult discussion, I know, is microarchitecture optimizations. I know there are some people who don't want to see it, and there are other people who do want to see it. So we're going to start taking a look at what that would mean in glibc proper and how it would be implemented for ARM and ARch64. I know some of you will be kicking and screaming, but it might happen.
Well, I have a use case, prefetching.
Okay.
I don't have a hardware prefetcher. So, yeah, that's the main thing.
All right, moving on. So GCC performance and features. We have a lot of code in flight. When I mentioned GCC 6 stage 1 closing, it's particularly with regard to some of these in-flight projects. We're doing a lot of work in auto-vectorization and auto-vectorization improvements. We want those to land in GCC 6. Coogan's also been working on value range propagation for zero and sign extension elimination for a very long time, and it's generated large amounts of patches and interest. And I think he's hoping to close that in GCC 6 stage 1 as well, right? Hopefully, yeah. Yeah, and it's actually seeing not just performance improvements, but use cases outside of zero and sign extension elimination. We want to continue fixing bugs we find in Linaro Toolchains. Yvonne just found a nice heinous one, out-of-memory bug. So we'll continue to find bugs with our toolchain validation and fix them. And we'll continue to analyze LTO, large applications with LTO, and looking for missed opportunities. We're also starting to look at using TACT, which is I don't know what kind of framework, what you would call it, but it's used for permuting through optimization flags.
Auto-tuning framework.
Auto-tuning framework, yep, to start identifying optimization opportunities. I want to return to intrinsics testing improvements. Oh, wait, intrinsics and testing improvements are are upstream now mostly. We have a question as to whether we want to expand coverage of those. It's not essential, it's sort of a lower priority. We might want to return to intrinsics improvements, performance improvements as well. And we're nearing the end of GCC 6 stage 1, so we can hastily put in a bunch of the modularization patches. I think we were working on target macro hooks recently. What we were doing was we decided to wait on the modularization patches until the end of the window because they affect so many header files, and we wanted to ease the backporting process by not introducing too many changes. So we'll have some time to get some more of those changes in.
There's a whole bunch of targeting changes.
Yeah, there's quite a bit of stuff.
I know that Richard Sandiford did quite a lot
Already in.
already, yeah. So
Yeah.
you may want to see what's
Already been
happening
done.
in trunk and what's been obsoleted by that work.
Okay, yeah. Well, we have a number of topics. I think there's 10 different topics in modularization that we're looking at.
Okay.
So we'll revisit it. Any questions on performance improvements in GCC or no? Okay. Oh, this is the same as last slide. Whoops. All right, moving into GDB. Yao is not here, but Yao is one of our assignees from ARM. He's a GDB global maintainer. He's been working on parity for the last 6 months. So parity with x86 as far as features and test suites. And he's been trying to bring up AR64 features to parity with x86. So he's been finishing up work on multi-arch support in GDB, trace points enablement for AR64, and fast trace points support. So that's just most recently. The list of his to-dos is actually bigger than, it's pretty ambitious. He wants to work on nonstop debugging. That's a parity feature. I'll skip kernel awareness for the moment. Work on display stepping, continued multi-arch support, frame unwinding, and commit level testing. The interesting one is kernel awareness. So there's been a growing desire for a kernel-aware GDB. So yes, that does, I suppose, is in competition with KGDB, but there's a desire to be able to debug applications from kernel through user space, all in one application or all in one binary. So that's a project that there's quite a bit of interest in now. We're mostly consulting on that and speaking with the community and coming up with designs. And one of the landing teams is actually working on an implementation. Yes.
So it is more like suggestion. Have you guys considered actually to integrating GDB with the CourseID library?
So CourseID, so that's an interesting project. CourseID itself is done in the kernel in the library. I was speaking with the kernel groups about who should be responsible for the library, and there's a question of whether it's Toolchain or is it kernel, and the kernel team has spun up their own community project to implement the library. And I think the idea is that debuggers or IDEs will use that library directly. So we aren't currently doing anything within the Toolchain to integrate it, but when it becomes usable, I think we will. But last I had heard, they're still in the design phase, so there's nothing usable.
Okay.
So let's take just a quick look at Linaro GC source releases. We got a great tool written by Yvonne that's now basically can backport pretty much anything. So he's been working on that. He is actually able to backport more patches than we can validate, which is pretty cool. So our validation infrastructure can't keep up. We're trying to scale, but like I was saying earlier, it's difficult. It's a difficult problem when you're trying to validate as many different configurations as we do. We're also looking at RMV 8.1. I was speaking with Ramana about patches landing upstream. I'm not sure whether those can be backported or not. I haven't taken a look at what those changes are.
So according to the FSF rules, they can't be backported because they're not really a regression fix. But that needs to be negotiated upstream. So this is not the forum for that negotiation.
Okay.
And those decisions need to be made by the AR64 target maintainers and the release managers upstream.
Okay, so as far as we're concerned, we'll wait on what we hear from FSF and see what they do. And then
I think we can backport it into our it is,
right.
if I understand well, it is a rules to backport it into GCC 5 FSF that is under discussion with maintainers, but as far as our concern.
It's not normal practice to backport features into a release branch.
So we'll have to consider whether it's something we want to do.
I even wonder whether
Makes-
we have already backported some of the patches to GCC.
Yeah.
8.1 is making it upstream, it's being reviewed. You know, it's been trickling out over the course of the summer. And I think we've pretty much got almost the last of the patches upstream.
Okay. Yeah, you're not the only one. There's other people too, so
So-
that's good to know.
Yeah, let's have that conversation upstream. Yeah. Is all I'm saying.
And we're also working on release scripting in development to improve consistency. So so we can get those snapshots and releases out more consistently on time. Let's see. Oh gosh, I gotta speed it up. Binary releases. I thought I removed one element. So we're consistently finding problems internally with our releases and trying to fix them. That's why if you're waiting on the 5.1 release for August, it's not out yet because we've been finding problems. And some of the things we found are bare metal multi-lib support, fixing library paths. I was just informed today that ARMv8L target is actually not generating the ARMv8L target code like we thought it was. So I'm gonna have to scratch that one off. We also added Python support in GDB for MingW32 and for Linux. The big thing to take off this slide is on the far right, the top bullet. We'll hold back any release, a buggy release, rather than release a buggy toolchain to you guys. I think it's more important to get you quality releases than it is to get something out on time. If you got a problem with that, come talk to me, and we can talk about what we can do. All right, I'm going to keep going here. Benchmarking automation. There's a lot of interest in benchmarking. Please see our presentation. That's on Wednesday. Our two main goals are release benchmarking and backport benchmarking. We are spinning that up. I think Bernie said it's almost ready to go. Almost. Secondary goals: aid compiler developers, and doing parity benchmarking. And I'm not going to say benchmarketing. But if forced to, I want to be able to give numbers when interested people come asking. All right, so LLVM, we'll move on there. There's a few projects here we'll discuss. LLVM proper, or the compiler proper, and the libraries, the linker, and sanitizers, and the debugger. So we continue to work in maintainership on LLVM, and this is actually taking up tons of time. We're also interested in a new project to work on integrating all of the LLVM hosted components, so libraries, compiler RT, libc++, linker. So presently, the LLVM community toolchain uses a combination of LLVM hosted libraries and GNU Toolchain hosted libraries, I believe. And we want to start moving toward an LLVM hosted solution entirely. So we want to put together some bots which test those combinations and verify that the fixes were.
We already have a field board that's mostly green.
Ah, you do? Good.
Yeah, the only problem is one of the tests takes 499 seconds to run, and sometimes it runs over 501 seconds and it times out.
Ah, okay.
But apart from that,
So if you see reference to an LLVM reference toolchain, that's what it's talking about. The continuous integration sort of framework that's verifying that you can build an LLVM hosted toolchain. It doesn't mean you're going to see LLVM branded or Linaro branded LLVM toolchain builds.
yeah, this is mostly to get people, members, and users that the libraries and the components work with each other, rather than that we need a full toolchain. It's just to make sure that if you want to use that component with this other component, they work together.
Yeah.
It's being tested.
So the far right bullet will dictate the bottom left bullet. So we're doing a lot of work in maintainership right now. We want to start looking at performance improvements, but we're doing a lot of work in maintainership. So there's a direct question there for our friends at ARM. We would love to have someone help out with keeping those bots green. I mean, that would be huge.
You're putting me on the spot, so I'm going to reserve judgment.
You could say it's a rhetorical question.
It's a
if you have
rhetorical question, yeah. Well, Arm's got a lot going on, so
Oh, we do already.
we do already.
Didn't I answer that? We do help out.
But the big part is keeping those bots green, right?
And we do. Renato gets to them before we do, though, unfortunately.
Yeah, I
So-
was telling him perhaps he needs to wait a few
Yeah,
wait
give
a
it some
few
warning
days.
time. We have an overnight testing process in our team, and part of that is checking public build bots for correctness regressions and performance regressions. Performance regressions is something that we care about that you guys can't do at the moment, so at least we're adding value there, and we do check that every single day. And we would fix stuff if they were red, but they generally aren't, so at least not for very long.
First, I must apologize. I didn't mean, I know you do all that. I didn't mean you didn't. That's not the point. The point is some direct work in the stabilization of the current build boards. Because if these is the context switch that it takes, it breaks down, any kind of more than 1 day work, it cannot be done because of the number of times. It's not that you guys are breaking or you guys are not looking. I know
It's the
you are.
volumes, right?
It's just to share the load of the interruptions, the number of interruptions.
Okay, I'd argue that we do. We have done a lot of work, an awful lot of work, in making sure that performance bots are stable.
I already
Performance
apologize that you know you're doing this.
Well, I'm not sure what else you want, really. We're already doing it.
So I'll sound all managementy. I'll say that, yeah, okay, we take the point on board, and we'll go away and we'll work on how to improve the situation.
Yes.
Sorry, that's
Sorry,
some
I
words,
wasn't.
but I do mean
I wasn't intending for it to devolve or anything.
Cool.
All right, so we'll go on. So sanitizers, we spoke about this before. Build bots are green, I've been told. We have them working in 39-bit and 42-bit virtual memory addressability. I think there are some ideas that have been brewed about dynamic selection at runtime. We don't have 48-bit support yet, but we should soon, well, as soon as we have kernel support. You had a comment?
No.
I had a question on KSAN down there. I heard a bit about that. I've been asked whether we're working on that. I don't know much about it.
What's KSAN?
Kernel ASAN. I think it's a fork built on ASAN. Yeah, so I've heard.
Even for ARM64.
Now the question is if they
Yeah, so with KSAN, everything, when I looked into it, it should all be working because all the problematic parts, like the virtual address space that we are dealing with in user space, kernel re-implements all those functions anyway. There is nothing to be done on the toolchain side as far as I know.
Okay, good. That was what I had thought.
So this talks about build boards that are in the upstream LLVM repository. What's the story with GCC? Because my builds on ARM, half the time I have to disable libsanitizer on AH32.
So,
I would ask that to you. I would ask you.
So I don't know. So I'm asking you because you guys are working on sanitizers.
so the process is always LLVM first and then GCC. So we just got 39, 42-bit working.
Okay,
So, I
so
think,
this is just about the LLVM support that's...
right. I
It's
don't.
about the sanitizers, right? The thing is, there is a process to move the LLVM, or the sanitizers in LLVM into GCC, and that's like Jakub, right, that does that job. And we can't test that ourselves until he merges from the LLVM repository to the GCC repository. So it's not something that we can do directly. Like even when Christoph was testing in the GCC tree, he had to move to LLVM to be able to commit to the sanitizers and then work back again to GCC. It's not something you can do directly on GCC.
I understand that. My question was more about what's the status today with the sanitizers? Is it?
It's upstream. It's whatever's upstream. We're not testing.
Okay.
All right, so I want to wrap up and then pass it on to Matt. We talked about LLD already. I just want to talk quickly or briefly about LLDB. Omer has been doing some great work on LLDB. He gave us a demo a few months ago of doing basic function, basically with remote debugging.
That demo was on ARM, so now the basic functionality also works on ARC64.
Great.
And ARM watch points and ARC64 watch points are in there in code, but there's some kernel limitations which are stopping us from sort of actually implementing them.
Great. So the next steps are?
Next steps are improvements on the watch point side and also on some of the features that we haven't touched right now.
Okay.
Yeah, that's it.
All right, Matt, I'm going to pass it to you. Cool. And you can just present off. Tell me to flip slides and we'll.
Yep. Cool. So I'm Matt Gretton-Dan. For those who don't know me, I'm the engineering manager for compilers at ARM. So I look after ARM's compilers that are dealing with devices that are in production today. So I look after the GNU Toolchain, LLVM-based toolchains, and also the commercial product ARM compiler. I'm going to point out, I'm going to embarrass people by pointing them out so that you know who to talk to if you actually want real technical answers to questions. Romana here is one of our GCC tech leads. James here is one of our LLVM developers. So if you've got questions about GCC or LLVM, go and talk to them. I also introduced Dan. So Dan's our product manager for GCC and LLVM and compilers in general. So if you have questions about roadmap that you don't want to discuss here or things, talk to Dan or I and we can answer your questions. Next, please. So I do a quarterly webinar, which it's called Matt's Chat internally, which basically we just try to give an update on what's basically this, you know, what we're doing, what we've done, what we're going to do next. If you want to get on the invite list, please do come and talk to me. I'd also love for Linaro and others to come and participate, so it's not just ARM. The idea is basically just to show what we're doing and try and make sure we don't step on each other's toes. So yeah, that's what I've just talked about. So our goals are, obviously we support the architectures and cores. So ARM is doing new developments. I'm not going to talk about them here because they're all because it's a public forum and the new developments are all private. But there's an awful lot of what we do private initially, and then the aim is that as soon as we announce a new CPU or a new architecture, support for that will go straight upstream. We want to support the community, fix bugs, just help the community with releases as they go along, and also improve performance. And as you'll see as we go through this, ARM obviously has more than just the A profile and 64-bit. There's the M profile for embedded, R profile for real-time, and the other bits of the A profile. So our team focuses on everything in ARM. So there'll be bits here that talk about R and M. Next, please. So yes, let's talk about the LLVM toolchain. So for the third quarter, we've been working on finishing off ACLE stuff. So ACLE is an acronym with no expansion, but did stand for the ARM C language extensions. Basically, this is a set of source level intrinsics and types and predefined so that you can basically use a Clang-based, LLVM-based compiler or a GCC-based compiler or other compilers without changing your source code. So we've been adding various support for that to Clang, various bug fixes. We've also been working upstream with the guys doing the LNT, which is performance bots, so that we're making the performance bots more stable, their website more stable, and just being able to start producing performance benchmarking numbers in public build bots. I suppose they have to be called performance bots rather than build bots, but you know, getting numbers out and people being able to analyze the data.
Yeah, that was a great job.
Pardon?
The LNT job, that was amazing work.
Yeah. So Christoph was doing that.
Yeah.
Cool. Next. Doing lots of optimizations. Some is done, some are in progress. Basically getting performance to improve, to keep product management happy. James has done some recently on, did you do structured loads? No, you were doing min-max idioms, weren't you?
Still structured loads.
Then there's scatter-gather loads, basically, in Neon. Improving Thumb1 code generation, not important necessarily for 64-bit, but important.
You mean
Interleave. Do they interleave? I get
They are
confused.
interleaved.
Improve Thumb1 code generation, alias analysis for static global variables. There's a famous benchmark which you need to do that for. And we've also been helping out, so AOSP Art had issues with using large amounts of stack space, and we helped out with stack slot coloring in effect, and improving the stack usage in Art. Next, now. So the next to be looked at are completing the optimizations. We'll once work on more optimizations, obviously, as we finish them off. So improve vectorization factor for loops, working on the smaller data types, integer data types, and we're also going to be improving LNT further. Do you know what's next on LNT?
I think Christoph's main goal is to try and, at the moment you can have a performance comparison, but sometimes it's a bit difficult to tell whether it's noise or real stuff. So he wants a way to be able to tell also what the assembly diffs were between two different things. So you can tell whether it was actually affected or not.
Cool, thank you.
And you got the code differences, the diff between.
That's the goal.
But he's already half upstream at least. There's something that tells that if the benchmarks were different.
That's somewhere
if
towards
the
like
binary,
goal, isn't it?
If the final binary is identical and the numbers are different, it means it's noise.
Yeah.
So then you can compute the noise off the base noise.
Yeah, so these slides were written about a couple of weeks ago because I'm trying to be organised, strangely, for me. Cool. So moving on to the GNU A toolchain, we helped the community release glibc 222. I like this statement, no known serious AR64 bugs, which doesn't mean it's bug-free, of course. We just don't know about them. But yes, basically trying to clear out the bug tracker and making sure that...
We did fix one major AR64 bug, which was more about races and TLS desk handling.
Yeah.
So that was one pretty big chunk of work that Shabolch did. So yes, that is the one big bug that we know about.
Yeah, so improved API support. So it turns out that LLVM added thread local storage support and did it using a different one of the memory models that was in the API to what GCC does by default, and we hadn't implemented all the memory models in binutils or the linker, and so we had to go and finish that work off to help LLVM team along, which, you know, you ought to at least implement your whole API, so.
Well, I found that funny when I heard about that, because we had proposed to do that last year, and you guys were like, oh, we don't need to do that.
No,
Yeah.
it was... it's a funny one, yeah. We didn't expect people to be using thread local storage with 4 gigs or something.
So there's the next one, the overline parameter passing issue fixed. That's an API change, subtly, and correction. So that is worthy of note. AR64 target attribute has been enabled. That improves LTO support, despite the fact LTO support doesn't work fully. But we're getting there. We have friends elsewhere doing that for 32-bit, so ARM's not doing that for 32-bit, I believe. Christian Bruhl's doing it. So upstream, so that's good. We're pushing, so 8.1a support's been enabled in binutils. As Roman has already said, I think all the 8.1a patches for GCC are now upstream. There might be one left.
There might be one outstanding, but
okay.
The majority of the work for GCC is now upstream.
What I have is a plea that anyone who's got any hardware.
Can you please test that on hardware?
I don't have hardware yet.
Right, then you. We believe they're correct. They need testing on hardware, on real hardware.
Hardware by the end of the year.
That's not close.
3 months away.
I just can't say when.
It needs to work for 6.
Okay, let's just leave it at that. I can't say exactly.
And also, we've been improving induction variable optimization. So we have a member of the team who's been working on that for at least a year, if not longer now. And as with everything with this, it's slow in incremental improvements and things are improving. And there's lots more to do on that as well still, but it's getting somewhere. Next, please. So the RM toolchain, not necessarily as important for this room, but just to show that we are working on it. So let's just move on. Next step, so glibc correctness for 2.23 release. You know, releases keep coming around the corner. We'll finish off 8.1 support, FP16 support. So there's the advanced SIMD intrinsics. We need to complete the support for Hyatt 64. We want to continue improving performance with the cost models. So ARM obviously only can improve performance on Cortex-A53 and Cortex-A57 directly because they're the cores we understand the microarchitecture for. People like Cavium or Applied Micro or whoever else has a CPU design. Qualcomm, oh, I don't know who else has who's public, so there's...
Qualcomm is public.
They will implement those in GCC, but using the same infrastructure, but making sure that works. We're looking at enhancing the GCC vectorizer, more loop invariant optimizations, ARM v7m execute only, moving Thumb1 onto unified syntax. Is that done now? That's done.
Yes.
That's done.
In fact, we should be moving the whole GCC backend, GCC ARM backend to unified syntax for 6.
Yes, please.
Yes, it will be done. Thank you. I have a patch for it, and it's mostly sane, so I'm going to commit it. It looks sane, at least in all the testing. I've had independent confirmation from another person in the community that it's looking sane, so I'm just going to commit it.
Okay.
However, inline assembler will still remain legacy.
Oh, that's fine.
Yeah.
Okay.
I'm not about to get people to change their source code just because we've changed.
No. Yeah. I know.
Okay. Improved API and ACLE compliance, as per normal, trying to just make sure you obey the standards. Yeah, so there's a new match.pd, there's tree matching now available in GCC. We want to just make sure that's being used properly. There are some CRC functions that could be optimized there. And then again on Cortex-M, improved selection of FP divide and multiply instructions where you can do that in hardware or wait when you have to do it in software. So that's that for Cortex-M. I'm actually going to hand over to Dan to talk this slide through because...
Okay. Thank you. Okay, so we have a team up in Manchester that are working on high-performance computing-related activities. Includes compiler work. It includes performance-optimized runtimes. It also includes libraries. So by the end of this year, we're going to launch a commercially supported library package, initially targeting BLAS, LAPACK, and FFT. This will get extended to include some additional packages that are common in HPC computing, things like Bliss or Atlas or Scholastica or Tau. There's several that we're looking at porting these packages to ARM, testing them, making sure that they work just out of the box.
Is this floating point?
Yeah. Sorry?
Is this floating point?
Yes. Yeah, yes. Yeah, they're math libraries targeting scientific computing applications. And we're also creating a microsite, so we're redoing the ARM website. We'll have a microsite dedicated to high-performance computing activities, so developers will know where to come to find out what type of hardware is out there, what kind of compilers are out there, what kind of libraries are out there. It's really focused at the software developer in that space.
What third parties are you guys working with right now, or can you say?
Yeah, so we've been...
Well, actually, there's another third party I'm thinking of that, actually I can say it because Pascal has announced they're working with Cavium, for example.
So we've been working with other vendors like Pascal to get their Fortran compiler working on ARM. Alinea, they've ported their debugger and their performance analysis tools onto ARM. So
also, what's the other one? There's what's the other one? There's another one, big one that I remember hearing about, but I don't know if that's public or not, so I can't say.
we can talk after because we've been working together with.
Yeah.
Yeah, if you have any questions about this stuff.
Have only been partially built.
And so the idea here is obviously we'll tune for the CPUs that we create, but we've got partners that are developing their own variants of that. And so we want to work together with those partners to make sure these libraries are tuned for those particular microarchitectures so that you always get the best performance on the device that you're running on. So that's really the goal here. Okay.
Yeah, I was just going to ask if anyone had questions. Give Christian the box.
Thank you. Yes, this is floating point, and do you have plan for ARM cores that don't have integer divide or remainder to do something? For instance, to speed up the emulation routines, which are maybe
so that's
a bit
basically
slow, or to try to catch in algorithm when you have both divide and remainder together, try to catch in a single operation.
Okay, so that's at the other end mostly to, actually no, it's not, it's sort of in the middle, it's a profile 32-bit. We don't have anything at the moment, but we can add that to the list. And between the
It's been on the list for a couple
times.
And it's been improved once or twice, or at least tried to.
So partly it's library work, some of it's compiler work to recognise the patterns, and some of it's library work. So we can certainly look at that, or put it on the list to consider, and we can see who does it in the community, whether that be ARM or Linaro or somebody else.
I mean, it's quite visible on algorithm that relies on divide and modulo.
Are there any other questions? All right.
Ask if you guys still have any plans of maintaining and expanding the Cortex strings?
Yes, so any of our optimization work, we intend to put into Cortex strings first before it goes into glibc. The difficulty here is that we're not the only contributors to glibc, so if other patches are slipping in, that will make porting more difficult. But we intend to continue to support Cortex strings. Just it has a permissive license, which then allows patches to go to Bionic as well as to glibc.
And do you guys have a roadmap of the things that are coming along? I'm asking this from the Bionic perspective.
Not that I can speak about directly immediately, no. But we continue to do investigations into what goes into Cortex strings. I know Bernie had been looking at some before he got sidetracked, and maybe he'll have time to return to some of those.
So here's a question. Is Cortex strings now misnamed?
So, yeah.
Because it's more than string routines now, more than just memory routines.
Sure, yeah, like a shared optimizations library, really. Yeah.
What's in there now besides the strings and the memory ones?
There's some math routines.
Oh, there are.
Yeah.
Intel has pushed recently on glibc a vectorization math library. Do you have plans to do something similar, open source?
So we don't have plans at the moment for a vectorized glib as supporting to glibc. We've noticed that that's coming this year, and we're considering what we're doing for next year. But at the moment, we have no plans for a vectorized math library. I presume you mean the vectorized sine cosine math library.
Yeah.
Yeah.
So those libraries are not going to be using
Then
SIMD anything, or this mean just...
Well, no, that's different. So that's Blaslin Pack and FFT.
Yeah.
glibc has recently added support for vectorized sine, vectorized cosine, which is different from that.
Okay.
Yeah, it's done x86 only.
Yeah, because if you don't use SIMD now, then just throw it away.
You know. So obviously, yeah, those probably use SIMD, but no, it would be useful for it to be on the roadmap, at least for next year.
Okay.
Because I think it will come up with the auto-vectorization work.
Come up in all sorts of places.
Yeah.
All right, guys, we got to wrap. we got to wrap it up.
Actually, I will add one more. I don't have a slide, sorry.
Oh, sure.
But that's because I've been so busy. So I can actually talk about a little bit about something that Cavium's been working on, structure reorg or structure layout, or a couple different names for it on GCC. So we've gotten to a point where we probably should have more help than just one person working on it. And we would love to have community support, Linaro support, ARM support, a few others, to be helpful on it.
Have patches gone upstream for
We will be putting out a branch in the next couple months. Should be soon. So I will force that issue soon after.
I'm sure people will take a look.
So it'll be nice. So the plan is to start only with libquantum right now, but we also plans on working with other C++ code. I think there's an open source graph walking algorithm code base out there that we also been using. It's C++ base, and it will actually could improve the code generation there by removing the layout of the structure to be more friendly to the cache hierarchies and everything. Yes, without breaking, well.
That's why it's so not generally applicable.
Yes.
It's just benchmarking essentially.
Well, actually, no. It will be if you can prove nothing escapes, then yes, we'll improve it. Yes, yes, it will be. It is using LTL. Some of the slides are on actually. Well, the presentation was done at the GCC Cauldron, GNU Tools Cauldron, so you can watch the video there. Anybody else have comments on it?
All right. Well, we're over time, so we're going to wrap it up. So thank you for attending. If you have other questions you don't want to ask in public, go ahead and come to me, or I assume Matthew is available as well. All right. Thanks very much.